with shape. If you look at the Earth is not, it's not a perfect, it's not a perfect spherical, and not elliptical again. Some what happened at equator, it will be bulged, and it is rotating about its own axis. So I'm interested in these points, point 1 and the next point 2. Look at the radius. So definitely what happened if you look at the radius R1, this R1, R2. Why do it is bulged? It is bulged at this particular point. If it were a perfect spherical, it should have come like this. Able to understand the diagram? If it were perfect spherical, I would have drawn like this. It's a circle here like this. But it is bulged at equator. Any reason for that? Some are telling because of pseudo force, centrifugal force. Because of centrifugal force, this particular mass or will experience a radial outward force, and that is making the Earth to be more bulged at equator than at poles. These are called like a poles. It is more bulged at equator than at poles here. One of the reasons they're calling centrifugal force. Means one fine day will it become like this? We don't know. We have to wait some easily some 2, 3, 4, 5 or around 100 or 200 billion years or 1000 billion years. Maybe the physics teacher after who is teaching after 500 or 1000 billion years, no, he may say that earlier in 2021 one physics teacher used to say like this. Okay, now what happened after after exactly 500 billion years? So this is a thing. We have to wait for time. Time will answer these things, not the knowledge. That one of the reason is telling why it is bulged more here is this one. To notice this, what happened? We need a long time. We need some to notice appreciable changes in the shape of the Earth. No, easily we need around 5,000, 10,000 years. That's why the scientists what happened. They are now present from the core of the Earth to the equator. What is the distance? They have tabulated and kept it. Maybe the future generations, when they look and if they see any difference, no, then they can start doing research. What actually can happen? Or if you have a time machine, if you go some thousand or like a 100 billion years forward and go there, see and come, okay, fine. It happens in movies all, they show time machine. If we get some time machine, yes, we can answer. Variation of G with the shape of the Earth. Where R1, so definitely I think looking at the diagram, R2 greater than R1, and we know, so this is G1 is equal to GM R1 square. And what is G2? GM R2 square. So as R1, R2 greater than R1, or say, let me put like this. R1 less than R2. So therefore G1 greater than G2. So where it will be like a acceleration due to gravity will be more at pole, it will be more than at the equator. Means suppose you stand here, you measure your weight, then you measure your weight. Where you feel happy? You feel happy when you are equator. No, you feel you are weighing less. G2 less than G1. Your mass is same, but you feel you are weighing less here. The weight of the substance here, it will be less compared to this one. And this, similarly, as you move like this, it all depends upon that radius also. So the shape of that also matters here. So usually the type of questions as the person walks from pole to the equator along the surface of the Earth, then you will feel that his weight is gradually decreasing. Correct? No? You'll feel his heavier here is lighter. Lighter means not very lighter. Small variation is there. This is about the